Assalamu alaikum. My name is Yasir Jamal and I'm joined by my two friends, Sayyid Muhammad Abeer Asim and Muhammad Yahya. Muhammad Yahya will again be handling the back end and the editing of the video, and Abeer will be presenting the slides, and I will be explaining the code like usual. Uh, Now I'm gonna hand it over to Abeer. Abeer, can you go on?
Assalamu alaikum everyone. Today our topic is Gauss Jacobi method in computer sciences. Now, first of all, I will introduce the topic. The Gauss Jacobi method is a powerful iterative technique that has transformed the field of computer sciences. Now, let's dive into its application and the introduction. Now, moving towards the next slide. Now, first of all, we'll see the understanding of the Gauss Jacobi method. That is, uh, it is efficient iterative approach. The Gauss Jacobi method is a technique for solving systems of linear equations iteratively and ensuring the accuracy and convergence. And secondly, it is applicable in computer sciences. This method finds broad application in computer sciences, computational mathematics, machine learning, and data analysis. Now, moving towards the next slide. Now, we have implementing of Gauss Jacobi method in computer sciences. First is step-by-step process. We learn how to apply the Gauss Jacobi method in computer sciences, including the iterative calculations and convergence and the other methods. And second is emphasizing accuracy. We'll discover the importance of accuracy in the iterative process, ensuring the reliability of the computed solution. Now, moving towards the next slide, we got what are the advantages of Gauss Jacobi method in computer sciences. That are, it is efficient in solving large systems. The Gauss Jacobi method excels in solving large computer systems of linear equations, making it ideal for complex computer science problems. And secondly, uh, it is it has a very good potential for parallel computing. We'll explore how the method I, we'll explore how the method is iterative nature enables parallel computing, maximizing the computational efficiency in modern system. Now, moving towards the next slide, we got overcoming limitations and challenges of the Gauss Jacobi method in computer sciences. The first limitation or the first challenge is that converging issues and divergence. We have to understand the potential challenges of the divergence and convergence issues while applying the Gauss Jacobi method in computer sciences. And second is that impact of the system size. We have to explore the correction between the size of the system and the computational resources required and how it affects the method efficiency. Now, moving towards the next slide, Yasir, can you move towards the next slide, please? Thank you so much. Now, we have the comparison of other iterative methods with the Gauss Jacobi method. Other iterative methods compare and contrast the Gauss Jacobi method with other popular approaches, weighing the pros and cons of each method, while Gauss Jacobi method dive into the unique features and advantages of the Gauss Jacobi method, making it stand out among other iterative techniques in computer sciences. Now, Yasir, can you please move on towards the next slide? Thank you so much. Now we'll moving towards the conclusion of harnessing the power of Gauss Jacobi method. That is, we have first of all the summary of benefits. We have a recap the advantages and strength of the Gauss Jacobi method in computer sciences, while emphasizing its versatility and efficiency, while importance and future research. That is, we have explored significance of the method in advancing computer sciences and highlights of the potential avenues for future research. And that's it for the slides. We got Yasir, and Yasir will explain the code of the Gauss Jacobi method. Thank you so much.
Thank you so much, Abeer, for explaining the presentation and the slide. Now we'll be moving towards the code for Gauss Jacobi method. So the code is pretty simple. There's nothing too much going on in it. Basically, To start off with the code, first we have a method called Gauss Jacobi method, of course, and there will be parameters in the code. There will be few parameters: coefficients, constant, initial guess, tolerance, and max iterations. And then we will have two variables called n and x. N will be the length of coefficients, and x will be the initial guess. And then we'll apply a for loop. In the for loop, we'll have max iterations, a range of max iterations, and then we'll apply, and then we'll put a new variable of x. It will be named x underscore new equals to x dot copy, and then we'll apply a for loop, and the for loop will be applied in range n. And then we'll have a new variable called sigma. And sigma, basically we have the formula of the Gauss Jacobi method, and then we have another variable. Is the same one as x underscore new, is just defining the index of it, which is I. And then it also has the formula of the Gauss Jacobi method, how it's going to be performed, and it converges to the solution. And then it will return x underscore new, x equals to underscore new, and then it will return none. None means did not converge within the specified number of iterations. So just in case if the solution does not converges within specified number of iterations, let's say we have an iteration of 10, if it does not convert in 10, then it means it will return none. So let's just keep it 100 for now. And then a simple method of print header, where the code will print out a header like this, and then we will define get float input. So this is a method for getting our output as float, not output, sorry, the initial input that we will be entering. Let's say we have three gases, right? So we'll put all three gases any random number, and they will be in float, of course. So this is a method for that. And we use a while true loop, and then we write try, and then in try we write a variable value equals to float input prompt, because it will prompt the user for float input, and then it will return the value in float input. And then we will raise an error except value error. Value error will be invalid input, please enter, just in case if the input is not float or it's anything else, let's say it's characters or string, then it will automatically throw an error that it's an invalid input. Now finally we'll be coming to the main method, where we will be calling out all our functions that we all our methods that we first made before. So in the main method, first we'll print out the header, so we'll call that method, and then we'll write our coefficients and constants, so we can write them as anything you want. Coefficients could be anything, constants can be anything. And then we print enter initial guess, nothing too much about it. And then we'll write the variable initial guess equals to get float input, so that it gets the float input. And then writing guess for xi plus 1, meaning this is going to be printing our initial first guess. Let's say our first guess would be x1, then our second guess would be x2, and then our third guess would be x3. So it basically plus ones to every variable. And then we apply for loop for I and range, and then the length of constants. Then we have precision. Precision is basically used so that we get a precise value for our answer, like the solution we will be getting, like the answer we'll be getting, it will be as precise as possible because of this precision. And then solution, will write a variable of solution, and then we will write the Gauss Jacobi method inside it, and then the parameters that we initially initialize in the start. Then we'll write if solution is not none. For example, if the solution is not none, like if we get if we get some kind of value, then we'll apply a for loop for I value in enumerate solution, and then print xi plus 1 equals to value. So it will say x1 equals to whatever the value we wrote, or whatever the guesses we wrote in float, of course. Else print the Gauss Jacobi method did not converge. Just in case the Gauss Jacobi method does not converge, or we don't get an answer in our iterations, it will print out the Gauss Jacobi method did not converge. And then that's pretty much it. I'll show you how to run the code as well, and what do we get. So when we run the code, of course we get the print header that we wrote right here and on this line, and then enter initial guesses. where we wrote here, and then it's gonna ask for guess for x1, which we wrote around here. Here, guess for x1, and then let the length of constants. So let's say our first guess is 4, and then it's gonna ask us, because it is iterating, right? Every time is going to be I plus 1. So I plus 1 is now it's gonna be 2. For the second one, we'll write 8, and then I plus 1 again is gonna ask for us x3. We'll write 5, and then we get the value of x1, x2, and x3, which are all pretty precise. That's why it has so many numbers. And yeah, that's pretty much the code for it. Basically, it's used to remind the value of x roots like x1, x2, x3. And yeah, this program was made by Tech Tribe Talks, and visit our channel on Tech Tribe Talks. Thank you so much for watching the video. This was our topic for Gauss Jacobi method. I explained the code, Muhammad Abeer Asim explained the slides, and Yahya will be editing the video. If you found this video interesting, please make sure to like and subscribe and comment on the video. And that's it for today's video. Thank you so much for watching. Take care and Allah Hafiz. Abeer, can you say Allah Hafiz?
Thank you so much everyone for listening us. Make sure to like, subscribe the channel, comment your feedback. Thank you so much. Allah Hafiz.
Allah Hafiz, guys.